Good morning, anatomy students. I wanted to take the time to make a video for chapter 2. That gets into the chemistry, and some of you don't necessarily have a comfort in chemistry, so it's not like chapter 1 where you can kind of just read the chapter and figure it out and just follow along with the PowerPoint, and some of you can because it just depends on your comfort level. So there is a PowerPoint that is on Moodle and you're looking at it here, but rather than clicking through the PowerPoint, I'm actually have a fill-in-the-blank notes, and that's what I'm going to use to do the video. But the PowerPoint has all the pretty pictures of it, and so you can also go to the PowerPoint. But I am going to go with the note page. So this is a periodic table, and I'll be flipping back over to the periodic table, and we'll be looking at the periodic table from time to time. So the note page looks like this, and it starts out with what is an element. So last lecture we talked about the smallest part of matter is actually called an atom. And an atom is just one single little smallest you can break it down into. It is not considered living. Okay, so an atom's not living. So what's the difference between an atom and an element? Well, an atom is one single thing. An element, you can have a bunch of atoms put together makes an element, but they're all the same type, such as it's all carbon or it's all oxygen, all nitrogen, etc. So an element is only made of one type of atom. Only made, my board is not looking too good this morning, but that's okay. Only made of one type of atom. Sometimes my board doesn't communicate too well. So for most abundant types, well, the most abundant type you have is oxygen, and then carbon, and then hydrogen. You got a lot of water in your body, you got a lot of carbon things going on. And then the fourth one is actually nitrogen. Okay, so oxygen, carbon, hydrogen, and nitrogen. And through A&P, we'll be using chemical symbols quite a bit. So I picked 10, the most common that you're going to see, and I would like you to know their chemical symbols. So oxygen, of course, is just O. Carbon, these are all capital letters, by the way. An element, when we do an element symbol, it's always a capital. If it has two, the second one is always lowercase. So carbon is just C, nitrogen is just N. Boy, my board is not doing well here. Oxygen is hydrogen. Calcium, sodium is Na. Potassium is not P, it is K. Chlorine is C and then an L. Iron is actually Fe. Couldn't use I because iodine had already taken it, so it's from the Latin word ferrous, like a Ferris wheel. Phosphorus is P, and then magnesium is Mg. I'm going to pause the video for just a second and plug my board in and see if I get a little bit better connection for writing. Okay, I'm plugged in now. We'll see if it works any better. I'm not sure if it will. And so hopefully you know the three parts of the atom. So an atom has these things called subatomic particles, and you should have learned those in high school. So it has something in the nucleus, the very center of the atom, that has a positive charge, and that is the proton. Okay, it says give their charge. The charge is positive for that proton, and it is located in the nucleus of the cell. Not the cell, I'm sorry, we're about to learn cells. Nucleus of the atom, okay, which is really not a real distinct structure. It's really just the center. So unlike in a cell actually has a nucleus as well. It's kind of complicated, but it's the same word, center area. But so the second part that's also hanging out in the nucleus is the neutron. And the neutron has no charge to it. It's neutral, no charge to it at all. Also in the nucleus of the atom. And then on the outside, we have, in the electron cloud, we have electrons. And the electrons are what we are going to care about as far as chemical reactions going on. And so that actually has a negative charge, and that is in the outer cloud, we say. Outer energy levels, etc. So as far as electron concerned, it does have a negative charge, but it also has almost no mass. It's so small. It's important because that's how we get electricity, but has almost no mass. So when we talk about the mass of the atom, we actually get the mass of the atom for the protons and neutrons together. And what determines an atom is actually something called the atomic number. The atomic number is probably one of the most important numbers on the periodic table. That is the number of protons an atom has. And this is what determines the atom, determines the element. Okay, I went off the screen there, I'm sorry. So it determines the element. So if I go to the periodic table, this number you see here, that is the atomic number. Okay, so we'll be using that number. The number down below, some of you were taught in middle school that that was the mass number. You were actually lied to. This is not the mass number down here that you're seeing, this decimal number. That's actually an average mass of the isotopes. The analogy I gave in class was that, you know, maybe our class average mass overall, as a class average, might be 152 pounds. Well, if I point to you, you may weigh 152, but you may not. You may weigh less, you may weigh more. So this is an average. So please don't use the bottom number for anything. We use it in chemistry when we do mole conversions and things. But as far as you're concerned, we're really not using the decimal number. Okay, we are going to find the mass number, but that's not. That's actually called the atomic mass. So if you were ever taught that that was the mass number, it was not correct. Okay, so that is not the mass number. Okay, mass number is actually for that particular element. It is the two things that have mass. So it's the number of protons and the number of neutrons added together. Not the electrons, because the electrons have almost no mass whatsoever. So protons plus neutrons makes the mass number. Okay, so again, not that number, not that number. So I've got some examples here. We're going to do A and B and part of C. We'll come back to C in just a moment. So we're going to do A and B. So what is the atomic number of this element? So again, atomic number is number of protons. So the atomic number of this element would be 8. And it says, what's the mass number? Again, let me just, for emphasis, this is the number of protons. And the mass number, of course, is your protons plus your neutrons added together. So you have 8 plus 7, so you get 15. Okay. Now we're going to go to this one. Our atomic number is number of protons, so that would be 19. Which is number of protons. Our mass number is your protons and neutrons added. So look, I'm not messing with those electrons right now. Not messing with the electrons. So 19 plus 19 would be 38 because that's our protons plus our neutrons added together. Okay. So on this one, our atomic number is 19 because that's our number of protons. And then our mass number would be 39 because that is our protons and our neutrons added together. Okay, not bad. All right, so then we're going to move on and find the symbol. So the symbol, we would use a periodic table. You use a periodic table to find the element using the atomic number only the atomic number. Atomic number on this one is 8. Do not use the mass number. I am using the atomic number, number of protons, not use mass number. We are looking at 8, and 19. So my 8 is oxygen and my 19 is potassium. Okay, so the way we write that is, well, this one was oxygen. And so you're going to see this different ways because some of you will have to take a test, some of you to get in nursing school. And so some of these questions may be, for me, we're just going to take, and now this is our symbol. And then when you put your symbol in the middle, and then the upper left-hand corner, here, or the right hand corner of this thing. So, we've been talking about that. That's when chemistry and anatomy start messing with each other. All right, the upper side up here, we're going to put the mass number, and it's going to be what we call a superscript. So it'll go up there like that. Okay, so this is oxygen 15. Now, later, some of you may in your classes see this same thing like that, and then you may actually see the atomic number right here. Some books don't put the atomic number because if you have a periodic table, you know it's 8. So you can do it this way or this way. Both are correct. So on this one, it was potassium. So we're going to put K. We're going to deal with charge in a moment. We're just doing symbol right now. And so we're going to put K, and then we're going to put 38 up on this one. If I wanted to do it the alternate way, we would put 38 here. Whoa, my thing freaked out. Hold on. 38 here and 19 here. So that's another way to see it. I would kind of like you to know both ways. And then on this one, it's also still number 19. Again, atomic number is what we use. And we would put 39 up here. So, okay. 39 and 19 if you want to do it that way. All right. Hopefully you're understanding that. So if you'll notice something, these are completely different elements. Everything's different about them. These two are actually the same element. These are both potassium. Okay, so this is potassium and this is potassium. So what's making them different? Well, the difference here is the number of neutrons. So they have the same number of protons as each other, meaning they're the same element. Their neutrons are different. These are called isotopes of potassium. An isotope means it's the same element, but it has different number of neutrons. So we say that an isotope are atoms with same number of protons, which means same element, but, let me scoot that up some, but different number of neutrons. Okay, so if you change the protons, you get different elements. If you change the neutrons, you get isotopes, and these are isotopes. And on the PowerPoint, there's a list. You don't have to know, but there's a lot of radioactive isotopes in our body, or no, I'm sorry, so sorry, not that we use in medicine for diagnosing things in medicine. So you're going to hear a lot of different radioisotopes, different bariums and cobalts and things like that. Carbon-14, they're radioactive, and they use them as tracers and things. So you're going to hear that in your career. So that's an isotope.